This problem, f of x is in a polynomial function x to the fourth minus 18x squared. Part A, we're going to find the intervals, the function concave upward, concave downward. How to determine that? We're going to use the second derivative, concave upward, positive, right? Upward, happy, positive, downward, not happy, negative. Just get the plan. And then part B, locate the local extreme using the second derivative test. So we're gonna use the expensive tool to find the job. Second derivative test, you're gonna have to find the f prime, find the critical value, and then you're gonna use the critical value C in the second derivative and check out whether the sign is positive or negative. And if the sign is positive, positive is happy, right? Give you the local minimum. Negative sign, not happy, but will give you the local maximum. This is a real short version of the second derivative test. And part C, locate the points of inflection. Points of the inflection, we're gonna use the hypercritical point from solving the f double prime equals 0 or f double prime undefined. And then we use the real number line to determine whether the sign change from positive to negative or negative to positive. The point of changing the sign is called the point of inflection or the inflection point. And part D, we're going to have the graph and put them all together. All right, let's get started. First part, we're going to find the interval that the function concave up, concave down. That means we're going to work on second derivative. First of all, before ABC, we're going to have to find the first derivative no matter what. And we're going to use the first derivative in part B anyway. So the first derivative, I'm sure everyone okay with that. So we have 4x to the third minus 18 times 2, which is 36 times x. The second derivative is 12x to the second minus 36. Okay. And now we're going to check whether which one concave up, concave down. So part A, we're going to work on finding the hypercritical point by solving for the f double prime equals 0. We disregard the f double prime undefined because this problem, the function is polynomial. So nothing to do with the undefined because everything is defined. Okay, the f double prime equals 0, which is from 12x squared minus 36 equals 0. This is equation involving power 2. I recommend you to keep everything in one side and then clean up or factor the common factor as much as you can. We have 12, we have 36. The common number is 12. We have x squared minus and 12 goes to 36 by 3 times, right? Okay. And then with the x squared minus 3, this one, if you factor more, going to be x equals x minus square root 3 times x plus square root 3. If you want to do as the taking square root method, make sure you include the plus and minus sign. So with this, we get the answer x equals square root 3 and x equals negative square root 3. So we have two hypercritical points. Okay, and how do we use this to determine the interval of concave up, concave down? We just draw the real number line for the f double prime. Locate those 2 points on the line, negative square root 3, positive square root 3. And your your f prime is in the factor form. I would recommend to use the factor form here because this is your f double prime. Okay, well, how about I use it? I bring it over to this area of the notes so you can see better. So negative square root 3 positive square root 3, and this is the line for the sign of f double prime. And f double prime in the form of 12 times x minus square root 3 times x plus square root 3 equals 0. So what we can do, oh, the pen doesn't come out, the ink doesn't come out. Anyway, to determine the sign, you pick the value on the right side of square root 3, same as what we did in the past to determine the increasing, decreasing interval. If you pick the number, the easy number, like you can think about square root 4, which is greater than square root 3, right? And square root 4 is the number 2. So anything greater than square root 3. So for x greater than square root 3, the sign gonna be positive sign here, positive sign here, positive sign here. So then the product gonna be positive. So we have plus sign. For anything between negative square root 3 and square root 3, the 12 always positive inside, not a big deal. But for the middle term, think about the easy number like 0, somewhere between negative root 3 and positive root 3. If you put 0 in this group, you get negative inside. Put 0 on the last factor, you get plus sign. So the product of these factors of the second derivative will be negative inside, negative there. And then the last interval is the same way. So you just think about any value that less than negative square root 3. For example, negative square root 4. So the 12 going to be plus sign. The negative minus negative to get negative inside. If you pick negative square root 4 plus square root 3, the result going to be negative for the last factor there. And then overall, the product of the sign is going to be plus sign. So we put plus sign on the left interval. Recall these are the sign of the F double prime. Okay, F double prime. For the positive one, I'm happy. Negative one, I'm not happy. Positive, I'm happy. So this way, I can make a summary as the interval for the interval of concave up, CU concave up, gonna be the left end, negative infinity to negative square root 3, and the other one is square root 3 to positive infinity. And then the interval of concave down, concave, CD concave down. I put the note here. This is concave up. And this one concave down. So only the middle one that concave down. So then just the interval negative square root 3, positive square root 3. Okay, so this is the answer for part A. Looks like a lot of work, right? Okay, and then the next one in part B it asks to locate the local extrema using the second derivative test. For part B, using the second derivative test, you're gonna use the critical point. The critical point from the f prime equals 0. And what is our f prime? We found it at the beginning. F prime is right here, 4x to the third minus 36x. So 4x to the third minus 36x equals 0. To find the critical point, solve it the way that we normally do. Factor the 4 and the x out, and then leave x squared minus 9 in the parentheses. Factor completely, x minus 3, x plus 3. Okay, just ignore the graph for a little bit. I will summarize it after we finish up the problem. So then, let me see if I can manage the area more. And
So
then
that means we have three answers, right?
there are 3 critical numbers, yes. So I'm gonna adjust my screen real quick. here. Oops, the mouse doesn't go. Oops, undo. Just a second. Cut here. Bring it somewhere to paste. Just leave it over here for now, and then finish up the part here. To use the second derivative, so this part is gonna give you x equals 0, x equals 3, x equals -3. We have 3 critical values. And how do we use these 3 critical values? We're gonna bring it for x equals 0, check the sign. What is the second derivative at 0? X at 3. What is the second derivative sign at x equals 3? And at x equals -3, what would be the sign of the second derivative? The second derivative that we found at the beginning is 12x squared minus 36. It's going to be x squared minus 36. Replace x with a 0. We got -36. Is that right? The x, sorry, it's 12 times x squared. So I missed that. So either use this form or the form that we factor completely. It doesn't matter. It might be convenient for this problem to use the form that we factored along the process of finding the hypercritical. So this is the same as 12 times x squared minus 3. And when you replace 0 in there, you get -36. And this one is the same way. If you put it in 12 x squared minus 3, where x equals 3, the sign gonna be, this is 9 minus 3 is 6, that's 72, the sign positive. And the case that we replace the x with the -3, the negative value 3 square, you still have positive, minus 3 gonna be positive 6, so the value come out 72, the same thing. So we care about the sign of the f double prime. For the sign negative, the second derivative, are we happy when we have negative sign?
No.
No, we are not happy. If we are not happy, so that means gonna be upside down, right? And for the positive side, we are happy. We have the open up like this. So from the icon, the goal is to use the second derivative test, right? If the sign of f double prime less than 0, and the graph is concave down like this. So we see the top of the graph, the top of the icon. So that means at x equals 0, gonna give the local maximum point. Okay, it's kind of opposite way, right? And then for the f double prime, positive inside, the graph concave up, and we see the lowest point of this icon. So then these 2 points gonna give the local minimum value. Okay, this is the use of the second derivative. So then what are those numbers? We're gonna have to compute. So the local max value is the function at 0, and the local minimum value is the function at 3, and the function at -3. So the function value, now you have to go back to original function. What would that be? X to the 4th minus 18 x squared. So it's going to be x to the 4th minus 18 minus 8x squared. 18x squared, sorry about that. So 18x squared, and evaluate when x equals 0. Same way over here, x to the 4th minus 18x squared. Evaluate when x equals 3. X to the 4th minus 18x squared. Evaluate when x equals 3. And then plug 0 into the function, so you get 0. That's the local max. And then the next one you replace with the 3. So we put, let me share the screen real quick. So x to the 4th minus 18 So let's clear this. X to the fourth, so we're going to be 3 to the power 4 minus 18 times 3 to the power second. So the value is negative 81. So put it back in here. And then the other value, we treat the same way. But negative side, when you replace into the expression, but you square it turns out to be positive. So these 2 points gonna give you the same function value. So the local max value is 0. The local minimum value is negative 81. Okay, so that's part B. Use the second derivative. And then part C to locate the point of inflection. So I'm gonna wrap up real quick. So give me 12:30. So point of inflection. So since the hypercritical at x equals negative square root 3 and x equals square root 3. So we draw the line negative square root 3, positive square root 3, and identify the sign of f double prime. And what we did, we already did the sign earlier, as you see over here, to determine the interval concave up, concave down. We just borrow it. So plus sign here, minus sign, and plus sign. If the sign switch from one to another, that means both points here, they are point of inflection because the sign switch from positive to negative and also from negative to positive. Okay, so when sign switch, that point is called the point of inflection. And now we're gonna look at the graph real quick. Give me 1 minute. So as you see, we obtain the local maximum occur at the point x equals 0, function value 0. Two local minimum occurs at negative 3 and positive 3. The graph concave up until negative square root 3, we concave up, and then concave down in the middle, that is from negative square root 3 to positive square root 3. So that's a sketch of the graph.